Today, I want us to start discussing the chapter on diffraction. It's Unit 2 on page 225 to 56 in your textbook. And first of all, I want to recap the basic properties of waves. So, I'm going to represent a transverse wave. Now, if there's no disturbance moving through the wave, it will be in its rest position. So somebody would be vibrating or causing a to and fro motion in the medium that would displace the particles, and if it's displaced perpendicular to the rest position or the direction of motion of the disturbance, then you would see that type of pattern. Right, what is a pulse or a vibration? It is a single disturbance that moves through a medium. So your pulse would be this part. That would be a pulse. It's like half a vibration. A vibration is a to and fro motion. A pulse is a single disturbance that moves through the medium. I think in your textbook they use pulse slash vibration if you look on page 225. Now, vibration is slightly different to the definition of a pulse. Next is the amplitude. Now, amplitude is the maximum displacement of the medium from its rest position. So the broken line represents the original rest position, and the amplitude will be from the rest position or up to form a trough, or down to the minimum, the lowest point, to form, up to form a crest and down to form a trough. So amplitude, maximum displacement. From rest position. Now, wavelength is the next definition. Now, wavelength is the distance between two consecutive points in phase. So I'm going to use that crest there and that crest there. They are consecutive crests. They follow, the one follows the other one. So the distance between the two consecutive points in phase, that distance is the wavelength. You could indicate it in other places as well. If I look at this point and that point, they are also in phase. So that distance there would also be a wavelength. By the way, just to recap grade 10 work, in which direction will point 3 be moving if the wave or the disturbance is busy moving to the right through the medium? What will 3 be doing? Will it be moving up or down? 3 would be moving up. What will 4 be doing? It will also be moving up because it is facing the oncoming crest. Right, next one is the frequency. Now, frequency is, per definition, number of waves per second. So let's look at our example in the diagram. Let's say it took 3 seconds to complete. Now, if we start counting, 1 crest, 1 trough, that's a wave. Another crest and trough, that's another wave, and a crest. So that is 2.5 waves. So what is the frequency of that wave? Frequency is number of waves per second. So it's 2.5 divided by 3. So 2.5 divided by 3. Dot 833 hertz. Following frequency, we get period. Now, period is the time to complete one wave. And if you look at the definition of period, it's time per wave. So you can calculate period, capital T, by taking the time and dividing the number of waves. But you can also use the frequency. So it's the inverse of the frequency. If we get the inverse of the frequency, the answer is 1.2 seconds. So it takes 1.2 seconds to complete one wave. That is the period of the waves. Next, I'd like to discuss the concept of points in phase. What are points in phase? Points in phase will have the same displacement at the same time. So, if I look at that point there, it's stopped at its maximum disturbance. So points 1 and points 2 would be in phase. If I look at point 3 and point 4, they are busy moving up, so, and they're at the same place, they're on the line describing the rest position, so they would be in phase. Points in phase would be an integer multiple of wavelengths from each other. So points 5 will also be in phase. They describe it beautifully in your textbooks. They say 2 points are in phase if they both simultaneously conduct the same motion and are equal distances on the side of the position of rest. Points in phase are separated by a whole number of complete wavelengths. Points out of phase will not be separated by a whole number of complete wavelengths. They would not have the same displacement at the same moment in time. So points 1 and points 6, 1 and 6 would be out of phase. Point 6 and 7 would be out of phase. 1 and 6 would be completely out of phase. So there's 100% out of phase. Number 1 is busy moving, or number 1 has moved to the maximum position, maximum disturbance amplitude. Number 6 has moved in the opposite direction to the maximum, so it's got a negative amplitude. So if point 1 on the wave and point 6 on the wave would coincide, they would cancel each other out. The disturbance will be 0. A transverse wave, you know what a transverse wave is. In a diagram we have described a transverse wave where the particles of the medium are disturbed at 90 degrees to the direction of propagation of the wave. A crest, transverse waves will have crests. That is the highest point on the wave, and they have troughs, which are the lowest points on the wave. A longitudinal wave disturbs the medium parallel to the direction of propagation, so it will have compressions and rarefactions. You can go to grade 10 to describe that. Lastly, I just want to show you what happens during superpositioning of waves. In the first diagram here we have crest and crest. Crest of one wave superimposed to the crest of another wave, and it makes a bigger crest. The same happens with the troughs, so you get constructive interference. The right-hand side of the drawing shows that a crest coincides with a trough, so you will get 0 disturbance, describing destructive interference. In the next video I will describe interference in more detail.